Good afternoon, ladies and gentlemen. I am Aniket from EDS Technologies, and I will be your host for today's webinar. First of all, we sincerely thanks each and every one of you for taking the time out for joining this session on empowering the space sector with advanced simulations. So before we begin, I did like to give a brief introduction about EDS Technologies. So EDS Technologies was established in 1994 and is the largest provider of technology solutions with a strong focus on PLM implementation and support. We are a partner of Dassault Systèmes and have served over 2,000 customers across various industries. Our presence spans 11 locations in India with our headquarters in Bangalore. We also have various strategic partnerships in additive manufacturing space. We have forged key strategic alliance with global additive manufacturing leaders such as EOS and Optomec, enabling us to bring cutting-edge metal and polymer additive manufacturing technology to Indian industries. We have our dedicated teams in sales and marketing and customer support to ensure that we met all your PLM business and service requirement effectively. Now, I did like to introduce to our technical speaker for today. So our speaker is Dr. Danish Handa. So Dr. Danish Handa has completed his PhD from IIST, specialized in field of composites, and has several scopes for indexed publications. He is currently working as simulation consultant for SIMULIA at EDS Technologies. He is using SIMULIA for past 12 years and has more than 3 years of industry experience. He also works with many composites manufacturers and research institutes to improve their existing design practices and methodologies. So over to you, Danish.
Thank you, Aniket. So good afternoon to all. The agenda for today's session is we'll start with the introduction. What are the challenges what we are having in aerospace industry? Followed by the composite modeling, its simulations, and what all simulations are possible in terms of aerospace industry in rubbers or metals, composites, etc. And then a small introduction about how we are doing the data management, as well as what all opportunities are there where our simulations as well as the management tools can work for you, followed by the question and answers from your side. So we all are very much enthusiastic about aerospace engineering. My background is also from aerospace. So we always see towards what are rockets, how these fly, what are the materials has to be used, how the aerodynamics will work, what kind of airflows will it happen. So all these space experience makers, we always go ahead and look forward to. But definitely, we always have some challenges, not some, basically a number of challenges what we encounter in our day-to-day life when we are working in an aerospace industry. So these challenges follows by what all kind of production we need to have, what all kind of cost what we have to counter it down. We have to work with new technologies which should be novel in nature because of the companies what are competitors of us. Definitely the sustainability. These are various key business drivers towards industry which caters space, which caters grounds, or which even caters marine. But when we talk about space, definitely cost is not much of a major factor, but sustainability as well as the safety becomes the major factor. But definitely when it comes with the reduction of cost, it becomes a boom, because we all have a business. So to run a business, we have to have a cost-effective business. One of the case study I want to show is like the certification challenge, because when we are into such an industry, definitely certification challenges comes into picture. So just a case study of like how the aerospace and defense companies do work with these particular challenges, especially globally. So in this case, I'm demonstrating an engine which also have some avionics components, some interior structural components. The requirements are it should be having a good functionality with respect to performance, safety, environmental aspects, etc. So n number of engineers are required to have such kind of scenario, that is mechanical, thermal, fluid, electrical, etc. And then some reports has to be generated. So definitely there are some departments involved and some tools, because physical testing and all will be definitely inculcating a huge cost. So how we can cut down the cost is due to our software solution, that is good CAD solution, good simulation solution, good testing software, even product lifecycle management, etc. So today we will be having an interest over these particular aspects. So this was one of the example which I showed, but definitely it is not one. There are several examples, there are several case studies, there are several challenges that aerospace industries goes ahead with. That is in terms of system architecture, in terms of powers, solar powers, battery modules, because nowadays we are studying and we are getting news that many of the industries are working on battery packed aircrafts, definitely fuel cells, entire avionics architecture. Then when it comes towards fluid dynamics, we have air flows, headwinds, tailwinds, gearboxes, all this comes into picture, and definitely the structural is one of the case. So we'll be studying that, how we can help you out with all these particular aspects. So I want to show you one video that Airbus, how it is handling smartly with respect to our solution. So this is a short video. So this is basically a smarter testing rig, which is very expensive, what they are using for their actual testing. But as I told, definitely these can be replaced by simulations by reducing the overall cost of the particular prototype, because many such prototypes are needed to be developed. You can visualize here, they have created entire test rig and how they are doing the simulations based on that. So Dassault Systems definitely give you a better view of how this particular test with respect to all your standards can be performed in a well-mannered environment. So from design to simulation to product lifecycle management to manufacturing, it can happen, handle everything. Yeah. So this was one of the videos that I wanted to show you before moving it further. So now I want to move ahead with the particular structural aspect. So as we are dealing with aerospace, so one thing comes into picture is how lightweight the structure should be, because the structure should be a lighter weight as well as of highest strength. That is how we can save cost because of the fuel efficiencies, because of the payloads what we need to carry. So it is very expensive in nature. So how we can reduce the cost, how we can have a better structure. So here I will be making you understand how the designing as well as simulation can be done into the particular software and how you can enhance the productivity of the components what you are making. So moving towards the first case. So if you can see here, we deal with different tools. So in this case, I will be demonstrating you firstly the CATIA composites. That is, CATIA is basically a designing tool, and composite module is introduced in CATIA to make complex shapes and structures. So you will be understanding how this is happening, and then we will move towards the kind of simulations, optimizations, fatigue analysis, as well as some kind of parametric and non-parametric optimizations. So this will make us understand how the interlink of designing and simulation plays a vital role. So as we can see here, the particular, this particular slide is towards the designing of a particular component, that is a fuselage component is here. So you can see that the detailed design is very important. Detailed designing of composites means the layup sectioning, how staggering is happening, how ply drop, how the overlapping of composite is happening. This is very much effective because the structures are very complex in nature. It is not uniform, so you need to have certain non-uniform thicknesses. So how it is performed? So if you can see, it not only handles the layup sectioning of the composite material, but it also can handle the manufacturing engineering. So we do have different softwares which can be integrated with CATIA to handle the manufacturability effect, such as hand layup, even laser cutting effect, even automated fiber placement effects. So all these things can be definitely very well handled with respect to the simulation. And how we do the composite designing is we do with respect to four different criteria. That is your manual ply, that is known as hand layup sectioning. Then we have classical zone approach, solid slicing approaches, and grid design. So I'll be demonstrating what all these things are. So first of all, manual approach. So as we do hand layer processes, that is we cut the prepregs or we cut the fabrics and we place on the particular aspect. So this is known as a manual ply creation, where you will be understanding what is the ply that you will be putting first on the mandrel or on the mold, and then you will be giving the material properties as well as the material orientation to the particular ply, and then you will be getting the manufacturing drawing out of it. And then there is a grid approach that is very much helpful because several sections are made up of different composite structure, maybe glass fibers, maybe some kind of honeycomb structure is there, maybe some kind of carbon fiber is there. How these particular all things are associated with different grids, different zones, it can easily handle. And then again, a classical zone approach is there, where you have some kind of edges, how you need to handle the stack up sequences, how you need to handle the staggering effect of the composite material. So these all comes into picture. And then the solid zone, even you can model the composite over a particular solid body also. So both surface body as well as solid body modeling can be easily performed. And then there is a grid design approach. So basically, if you talk about the wing structure, it is tapered as well as some kind of a tapered structure with the non-uniform thicknesses. So here the approach of a grid is very much necessary, because you have to bifurcate your wings into small sections to have a certain amount of ply stack up into it. So this stacking with respect to the wing structure is performed in a very uniform manner without much of a complex in your drawings. This was regarding the designing part. So now we are coming towards the manufacturing part. So as you know, there are a lot of manufacturing processes available for manufacturing composites, such as your hand layup or resin transfer modeling or kind of tape winding, automated fiber placement. So this particular software integrated with our manufacturing software can handle the manufacturing processes very well. So you can understand what is happening with what kind of manufacturing process. It will be very easier for us to establish this particular environment. So you can see here, for example, a particular component is there, how the draping effect is happening, what all kind of bending will happen in the fiber, whether the fiber will be having a kind of kinking effects or not. So these all things will be understandable in a very better format. Then again, smooth regions, where the regions will be again can handle the curvatures or not, how the simulation can happen. So all these things will be very much suitable for you. And then of course the braiding effects, this is also one of the very common manufacturing process and very important also, because nowadays all kind of ducts, pipes and all are made up of braids. So these kind of effects can also be very well modeled and simulated. And then very important process is composite forming, that is with respect to your resin transfer molding, or in case of high compression, maybe the compression molding process, or high compression molding processes can be easily molded using our tools. So you can see here a robot is there. It is picking a composite fiber and it is being molded and cured. So this is how you can easily do the simulations and check how your fiber has to be cut, how much pressure is required, how well this integration will be there with respect to the forming, what is happening inside, where the effects of molds are occurring on the fiber part, whether everything is fine or not. So you can develop a good mold design as well. So this is the benefit. Then of course you have to manufacture the part. So this particular software gives you the probability that you can model each and every layer. For example, there are 10 layers in your composites. So how to cut each layer, what each layer looks like. So it will show you what is the better way to cut your layers. Basically an open view or a section view of a particular layer sectioning. So it will automatically tell you that, okay, this way if you cut, this is better way to cut the fibers. So it will save a lot of amount that is going ahead with manual cutting of fibers, which may again have a huge cost when manually cutting, and this can basically save a lot of money. Then we also have a digital manufacturing software, which like for example, I've showed you that how robot is carrying the material. So this particular software integrated with the modeling tool can help you out with all kind of layer cutting, sectioning, all these probability things. And you can see here how it can help you out. Basically the laser projections or automated fiber placements, or even with hand layup, you can see how the how the fibers has been cut here. You can visualize the effects of single layers and how it has to be placed with respect to lasers or with respect to the hand layup or automated fiber placements. So this can definitely be very much helpful in your field. So this was all about the manufacturing, or all about the designing aspect. So we also do have solutions for simulation aspect. So what happens is there is two way to do the simulation. So our tool, as I told you, CATIA Composites, is for designing, and SIMULIA. SIMULIA has four different portfolios into it. That is your one is known as Abacus, which can work in any kind of structural software, structural solutions with respect to composites, with respect to metals, with respect to alloys, with respect to foams, etc. And we also have a software known as FESAFE, which can do fatigue and durability analysis, but it is only confined to metals. It is not applicable to composites, but we do have some modules for weld analysis, for rubber analysis. So, and we also have the software known as Tosca, which can do topological optimization in terms of reducing the materials and increasing the strength. Then we have eyesight, which is known as parametric optimization, which can perform your parametric studies, which can do n number of iterations for you automatically just to give the tolerances. So all this level of simulations can be done. So as I was telling, some basic level of making of layups can also be done in Abacus. So this is an Abacus GUI. So you can see there is a plate, and in the plate, the center portion is having some 10 layers, and the side portion normally is having 5 layers. So you can see the representation of these orientations also. The thickness will be there, ply numbers will be there, and the orientation effects will be there. So if you want, you can also have the angles of the orientation written over here. So like that, in the side portions, there are 5 layers. So this is kind of a tapered body. So this visualization effect also is not present in any of the software except Abacus. So it will give you a very clear-cut information what kind of modeling you are doing and what not you are doing. And then we also works on testing. So we have a fracture mechanics theories based on XFEM methods, that is crack propagation technique. We work on realistic fracture models. For example, for metal, we use Johnson-Cook criteria. For cements, we use JH2 model. For composites, we use Hashin damage criteria. Different criteria are there for viscoelastic materials, hyperelastic materials, foam materials, etc. So like that, we when it comes towards anisotropic materials, we use entire anisotropic properties of the materials. Nowadays the era has shifted. Earlier era was okay, we are doing some linear simulations, it is okay. But now you have to do failure analysis, you have to do fracture analysis, you need to give the warranty to the your OEMs for having this particular component. So all these things are required a lot nowadays. So you can also do some kind of tensile testing with respect to crack propagations. You can get the realistic effect of how the stress strain curves are obtained. You can obtain stress strain curves as well in the software. And you can also analyze the particular form in terms of ply. So what is happening in a single ply? Because when you come toward composites, we don't firstly go to head with respect to the thicknesses. We always works what happened with the single ply. So that can also be visualized. This is one of the case study for drones. So you can see here some different parts has been integrated into the particular assembly level. So once these parts are integrated, we are giving the material properties in terms of composites, in terms of aluminium, etc. So different parts are having different material properties, and based on that, a fracture analysis on the wings has been studied. So if the loads are very high on the wings, how the breakages of the wings in terms of composites happens. Then this is another case study where an entire aircraft is aligned, and you can see the properties which has been used are totally anisotropic, as well as the damage property has been given. And output of that is the aircraft is against a rigid wall, how it is getting basically crashed, and what happens to the entire aircraft. The damage will be very much near to what are we are getting the experimental in terms of crushing of a particular fiber reinforced composites. So this is how the entire scenario is been developed. And we also have a very nice tool for simulation of rubber bushing, rubber gaskets, etc. So you can see the difference between the deformable part and a non-deformable part. So entire non-linearity is taken care with respect to contact and convergence in our tool. And then you can also see how the self-contact has been inculcated here. So it's a completely realistic models. And these are some of the benefits and differentiators. That is how advanced producibility we can provide, how we can reduce the time to the market, because there might be many prototypes that you will be testing, because it's an aerospace component and it has to be a lot of safe and secure to provide it to the manufacturers as well as to the industry. So we need to be very much optimal in the approach. So these tools can definitely help you out with all the optimum designs with lesser weight, higher strengths, etc. And this was about the designing part as well as simulation part. So we also have a solution for your data management, with which you can do the inventory management system, product lifecycle management. You can always have the up-to-date version of your drawings, because there might be n number of changes you might have performed in the designs. So we work with end-to-end solution, that is your start to the manufacturing processes. So here you can see the entire chain management, as well as how the changes has been done in different versions are done. Even you can have your data management also. So how you can basically compare the data with respect to several designing aspects. So that also can be very well performed here. So you can track all the changes what are happening in the organization. That will be very helpful and very useful to you. And benefit of this particular software is it comes with both on cloud as well as on premises. So if you are going with an on cloud, so what happens is, even you are sitting anywhere in the foreign country and your team is working in India or anywhere else in the world, so you can just visualize the results or visualize the targets or versions in your mobile phone itself. So you don't need any software for that. Only one application is required and you can access entire data. So this is not very simple, because you, for example, you are the person who is having the license hold. So you can only give the particular access to the person who can view or who can edit this particular data. So it's very much secure as well, because sometimes what we are worried is that it is aerospace industry, so we need to secure our data. So data is 100% secure in the Dassault cloud. So that cloud is specifically given at a particular login IDs. So only the person who has the access for the login ID can give the access to others. So it is very much like secured. Then if you can see that this is one of a kind example where you can provide your bill of materials from the same application, that is our software, and you can manage your entire data with respect to the solutions what you can provide to your organizations. And so as I was telling, so this particular webinar is to understand how the things work from the starting to end. That is from system level engineering to data management to uh, do simulations in a multiphysics environment, to do provide some designing of a particular workforce, to the manufacturing aspect of the particular component. So we can handle each and every aspects through our solutions. And the benefit is you don't require any kind of different tools for different studies. So we have a single GUI system where in an integration you can have all these particular software. So it's a role-based software that can provide you all these particular data. And few examples that I couldn't show in the previous slides was like, it's not only the structural or like designing, but we also have solutions for flow analysis in terms of realistic environment settings, in terms of acoustics, in terms of electromagnetic challenges, structural challenges, and even your noise and vibration, your vortex flows can be handled very well. So we have solutions for all these scenarios as well. And nowadays, like EV has been in trend, hydrogen fuels has been in trend, even the lightweighting effect, the challenges with respect to motors are there. So we can cater all these challenges. And this is another plugin what we are providing free of cost to the customer. Is nowadays hydrogen fuels or hydrogen cylinders are very much in trend, and people are working on these particular aspect in a very broader way. So we also have a plugin where you can design your own mandrel, you can design your own layup sectioning, and you can understand how much pressures or what kind of effects can be understood with respect to the making of cylinders. So we do help with the virtual twin experience that cater you with the certifications. So from generative design to fluid dynamics to flight loads equilibrium towards parametric optimizations, non-parametric optimization, and final structural requirement checks can be fully integrated into the particular aspects in our solution that can be helpful in generating of the particular certifications which you can have from the different organizations. For example, in our case, DGCA in terms of aircraft industry. So these kind of things can be very helpful when you work in a particular environment. And towards the opportunities, I would definitely like to tell you like how we can scale up. So for example, we have these kind of capabilities. So even the bird striking effect can be understood in terms of radomes, in terms of antennas, sensors, wing. This is one of the very common problem occurring in aircrafts or spacecrafts. So that can definitely help some of the companies to understand it better than your aircraft engines, which has flange, blades, some material modifications, or how these RPMs can be effectful. So you can definitely have some kind of studies there. And one of the major importances towards the aircraft seats. So you might be knowing that a lot of research is being going on towards the seating of the aircraft, how we can make it better, how we can make it lightweight or multi-faceted. So these kind of things can be done. Then airframe structure. Now you know that much of the airframe structure is not a monolithic material. So it has changed towards a composite material. So how the structural aspect can happen, how the tailwinds, headwinds can affect the particular thing. And of course, the validation with respect to the original model or original component can be very well integrated in that. So we not only sell the softwares, but definitely we have a complete business plan for our customers. So we provide on-site trainings, we provide offline, online both trainings. We do have a setup where our customers get everyone free of cost trainings from our side, which can help them in understanding the softwares well. And then we also have a dedicated support team which are available and which are very much transparent in solving your problems. So we look forward to have a collaboration with all you industry people and even colleges, because we have catered to a lot of colleges in these particular terms, especially tier 1, tier 2 colleges. So we are looking forward towards a good collaboration where we can help you out with these aspects and go ahead well in the future. So thank you so much.
So now I would like to thank Danish for delivering a very insightful webinar today. And I'm very confident it was very helpful for our audience today. I also would
Thank you.
like to thank our audience for taking their time out and joining this session. If you have any further queries related to the subject matters or any other requirement, you can always connect with us. Our details would be displayed on the screen. You can reach out to us at any time and we would be happy to address your queries. Please do keep an eye on our upcoming seminars and webinars. You can follow us on our social media platform for the same. Thank you, everyone.